Good morning friends, welcome back to Relief Tutorials. In the previous lectures we discussed about reflection of light, laws, mirror formula, different types of images, and lastly the numericals. Now the second half of the chapter, and that is refraction of light. If light ray falls on one of the opaque substance, we know that light bounce back, and this phenomena already we discussed, it is called as reflection phenomena. But now the topic is when light falls on one of the transparent medium. Consider here is the water surface and it is transparent. When light ray falls on this, what happens? Because it is transparent medium, most of the light will pass through. Very little amount of light reflects. When we are discussing about refraction of light, we are going to ignore this part. We want to see that what exactly happens to the light which goes inside water. This phenomena of passing the light in the medium is called as refraction phenomena. Some light bounce backs, but we are not going to consider that part when we are discussing about the refraction. So, what exactly refraction means? When the light ray falls on one of the transparent medium, it goes inside, it passes through that medium, and during that what happens, that we have to discuss in the refraction. Let us see. See, in vacuum, speed of light in vacuum is 3 into 10 raised to 8 meter per second, or we can say it is 3 lakh kilometer per second. So when the light ray is traveling in vacuum, there is no resistance in the vacuum. We know there is no material particle is present in the vacuum. So light ray can travel with the maximum speed, and that maximum speed is 3 into 10 raised to 8 meter per second, or 3 lakh kilometer per second. From vacuum is one of the transparent medium, obviously. So from vacuum, when it enters in some other transparent medium are air, water, glass, one of the chemical called glycerine. We know about the diamond also, kerosene, and many other transparent medium we can discuss. So from vacuum, because in vacuum there is no resistance, so light can travel fastest. When it enters in some other transparent medium like water, like glass. Now if you think about water, consider this is water, and above it let us consider it is air, and above air we have vacuum. If you think about atmosphere of earth, if you think about the ocean is a water medium. Above ocean there is the atmosphere, and above atmosphere we have vacuum. So when light ray enters from vacuum to air, so vacuum and air, in air we have some gaseous particle present, but we know the density of air is very less. So the decrease in the speed, obviously when light enters from vacuum to air, the speed of light slightly decreases because of the resistance provided by these particles of air. But the fact is, the density of air is very less, so the decrement in the speed of light will be also negligible. Okay, then also somewhat speed is decreases and light travels like this. Now it enters in water, and we know water particles are having some sufficient density to oppose the speed of light. So when it enters from air to water, now there will be the notable change in the speed of light. Now the speed of light decreases very much. Because of this change in speed, listen to me carefully again, the speed of light in air is higher as compared to speed of light in water. In water, the speed of light will be obviously less than the speed of light in air. So because of this change in speed, remember this is the very important point, that because of this change in speed, light ray deviates from its original path. See, this is the ray. This is its original path. Consider this is the original path. But because the speed is changed, light cannot follow this path. Light will be deviated from the original path. This was the light ray, and this is the straight imaginary path. Consider there is no change in the path. But because of water, the change in speed, the speed will be changed, and due to this change in speed, the path is deviated. And this phenomena of bending of light, see the light ray bends. See, the light ray deviates. This phenomenon of deviating of light due to change in speed is called as refraction of light. So what exactly refraction means? When light ray enters from one transparent medium to another transparent medium, because of change in speed, the original path is slightly gets deviated. This phenomena of deviation of light due to change in speed is called as refraction of light. In vacuum, the speed of light is 3 into 10 raised to 8 meter per second, the fastest. As we have seen that when the light ray enters from vacuum to air, air is also very rare medium. Rare means having the very less density. Rare medium means having very less density, which cannot oppose the speed of light. So rare medium, air is also very rare. So what we consider? We consider the speed of light in vacuum and in air, both are 3 into 10 raised to 8 meter per second. So air and vacuum both are almost very rare medium. So when it enters from such type of medium to another medium, the speed of light changes, and because of this change in speed, original path of light is deviated, and this bending of light is called as refraction of light. So let us see the definition of refraction of light. Definition: when oblique light ray enters from one transparent medium to another transparent medium due to change in speed of light. Original path gets deviated at the surface separating two media is called as refraction of lengthy definition, but easy I think. When oblique, what do you mean by oblique? Oblique means, consider this is again water. Here is water and here is air. So the light ray should be oblique like this. It should not be perpendicular. It should not be perpendicular to the surface. Here the word is an oblique. So only those rays can be refracted which are oblique. The light ray which is making 90-degree angle with the surface will not get refracted. Very important. The light ray should be oblique. So when the oblique light ray enters from one transparent medium to another transparent medium, like from air to water, water to diamond, diamond to water, kerosene to glycerin, glycerin to water, whatever it may be. So when oblique light ray enters from one transparent medium to another transparent medium, due to change in the speed of light, original path gets deviated. The original path will not be followed. Now from which point the path will be changed? It is changed at the surface separating two media. Means this is the border of air and water. So from this border only the path will be changed like this. Consider this is air. So oblique light ray enters like this. So from this point the path will be changed. The original path was like this, but it will not be followed, and this is the so this ray is called as incident ray, and this ray now called as refracted ray. So due to change in the speed, the original path gets deviated at the surface separating two media. So this is the surface separating two media, the border line. The border between two media is also called as interface. So this border means the surface which is separating two media is also called as interface. So from interface only the path will be changed. This phenomena is called as refraction of light. Now, just like the laws of reflection, we have seen the laws in reflection part. So we have some laws to follow of reflection part also. Consider again, this is interface between the two medium. This is medium number 1 and this is medium number 2. Let's not give any name to the medium, but they are two separate or two different transparent medium. Ray goes like this. So this ray is called as incident ray. This point is called as point of incidence. At the point of incidence we can draw, as usual we can draw normal, just like we have drawn the normal in the cases of mirrors. So this is interface. This is point of incidence. This ray is incident ray. Now this is the original path, but obviously it will not be followed. Let us say this is the deviated light ray. Remember one thing. Consider this is medium number 1 and this is medium number 2. If medium number 1 is rare and medium number 2 is denser, if the light ray goes from rare medium to dense medium, when light ray goes from rare medium to dense medium, the refracted will be bent towards normal. Look at this. This is the original path and the light ray bends towards normal. In which case? The case when the light ray goes from rare medium to dense medium, light ray bends towards normal. If it is like this, if medium 1 is denser as compared to medium 2, then what? This is the oblique light ray, this is its original path, this is normal. Okay, this is incident ray. So now it will move away from normal like this. It bends. Diffraction occurs in both the cases, but the bending will be in the two different directions. When light ray enters from dense to rare, when light ray enters from dense to rare, the refracted light ray moves away from normal, and when the light ray enters from rare to dense, it bends towards normal. Okay. Right now, consider this is the case. So now this angle between incident ray and normal is called as angle of incidence, and angle between refracted ray, this ray is refracted ray. Okay, so this angle is called as angle of refraction. Now this is angle of incidence and here is the angle of refraction. Now let us see the laws of refraction. The first law that incident ray refracted ray and normal always lies on the same plane. I think this law is same as the first law of reflection. Incident ray, normal and refracted ray all lies on the same plane. If you remember, this is mirror, the laws of reflection, that this is incident ray, this was the normal and this was the reflected ray. All these three lies on the same plane. And now what was this is angle of incidence and this is angle of reflection. The second law in the reflection case was that angle of incidence is always equals to angle of reflection. But here in the figure we can see that these two angles are not same. In the case of refraction, these two angles are not same. If you compare geometrically, this is interface. If light follows the same path and if it is normal, then these two angles are same. If light follows the same path, but we know the path is not followed, the light ray bends like this. So now these two angles obviously will not be same. Now if it is not same, then what should be the relation between these two? So this is the quite important second law of refraction, and it is giving you the relation between these two angles. But before going towards that, let us see one mathematical concept. Consider this is right angle triangle. This is 90 degree. These are the two acute angles of this right angle triangle. Consider this triangle is ABC. Now we know the sum of these three angles is 180. This is already 90. So now these two angles are complementary because the sum of these two will be 90, because this one angle already will be 90. So if you consider this is 30, then this will be 60. Okay, so this is 30 and this is 60 and this is 90. Now in trigonometry, one of the chapter is there in your math syllabus, trigonometry. You will study in the maths, but let us see some basic information. In trigonometry, see there are some ratios. Consider this is our angle under consideration. Angle A we are considering as a angle. So now according to this angle A, opposite side is BC. Opposite to angle A, there is side BC. Opposite to angle C, there is side AB. Now if you think about angle A, from angle A, opposite side is BC. From angle A, adjacent side is AB. Adjacent side is AB. Adjacent means nearby. And this side is obviously called as hypotenuse. The opposite side of 90 degree angle is always called as hypotenuse. So the name of this side is always fixed as hypotenuse. Now left got two sides, this one and this one. Now if you consider angle A, BC will be the opposite one and AB will be the adjacent side. Now if you consider angle C under consideration, so from angle C which is the opposite one? From angle A, opposite one will be AB and adjacent side is BC. But this is always called as hypotenuse. Now in the right angle triangle, for every right angle triangle, consider this is angle A, B and C. B is right angle. Now if you consider A is the angle under consideration, means as per the point of view of angle A, BC is opposite side, AB is adjacent side and AC is hypotenuse. So let us consider A is the angle under consideration. So corresponding to angle A, BC is opposite side and AB is adjacent side. Now, three different sides are there. So in trigonometry, the ratios are formed like this. Consider the ratio of opposite side to hypotenuse. Ratio of measurement of opposite side to hypotenuse. Consider this is, let us say, the measurement of this BC is 5, AB is 12 and AC is, let us say, 13. Now what would be the ratio of A is the angle? See, first of all we have to decide the angle and that angle is A. Now corresponding to angle A, the ratio of opposite side to hypotenuse. So corresponding to angle A, ratio of opposite side to hypotenuse. Now what is opposite side? BC. Name of the opposite side is BC and hypotenuse is AC. So it is what? BC by AC. Later on we can put the values also. Now corresponding to angle A, the ratio of adjacent side to hypotenuse also can be found. Different ratios are there. Now adjacent side is 12, means otherwise the name is AB. So adjacent side is AB and hypotenuse is AC. Such many ratios. Opposite side to hypotenuse ratio corresponding to angle A, corresponding to angle A, adjacent side to hypotenuse, corresponding to angle A, opposite side upon adjacent side, corresponding to angle A, hypotenuse upon opposite side. Number of ratios can be formed. 6 different ratios we can form. We don't have work with all 6 different ratios, but every ratio have a particular name. If the ratio is always of opposite side to hypotenuse, that ratio is called as a sine ratio. If the ratio is of adjacent side to hypotenuse, that ratio is called as cos ratio. If ratio is of opposite side to adjacent side, this ratio is called as tan ratio. But every time behind the name of this ratio, we have to give the name of the angle corresponding to that. Which angle you are taking under consideration means as per the point of view of which angle you are deriving these ratios, that we have to do. So this is the way. Let's do some small practice. Consider this is P, Q, R. The value is here 5, 12 and 13, let us say. Now if I ask you what is sine P? So sine P means P is the angle under consideration, one thing. And sine means always opposite upon hypotenuse. Okay, now what is opposite of P? So opposite of P is QR. So it is QR and hypotenuse is always PR. Now put the values QR by PR. QR is 12 and PR is 13. So it is what? 12 by 13. If I ask you what is sine R? So R is the angle under consideration. Sine means always opposite upon hypotenuse. But now as per the angle R, which is the opposite one? The opposite one is PQ. Opposite side PQ. Hypotenuse is fixed as PR. So the answer is 5 by 13. This is sine. This is sine function. In maths it is called as function. It's the name of the ratio. Now what is the use here? So in the second law of refraction, let me write the law here. Second law of refraction is also called as Snell's law. Second law of refraction is also called as Snell's law, and what this law is? This law is giving you the relation between incident angle and refracted angle. So the law is like this. Ratio of sine. See, when I write sine A, sine B like this, you can write sin, but when you are not writing angle behind it, spelling should be sine. If you forget to write e in the law, doesn't matter, don't take it light. Ratio of sine of angle of incidence. Ratio of sine of angle of incidence to sine of angle of refraction always remains constant. The ratio of sine of angle of incidence to sine of angle of refraction always remains constant. The law is still continuous. It's a half law. Still one more statement is there. But first of all, let us analyze this statement. Ratio of what? Sine of angle of incidence. Sine of angle of incidence means it is sine I. Sine of angle of incidence to sine of angle of refraction means sine R. This ratio always remains constant. Still, as I said, law is still incomplete. We have to derive the value of this constant. What is this constant for? But it's a long topic, so it will not be covered in this lecture. So that is all for today. Only the things we have seen in this lecture is definition of refraction and two laws, but the second law is still continuing. Best of luck.